Hello, we are Group 5. My name is Cody Rodell. I'm a geological engineering major and I will be graduating after the semester.
Hi, I'm a fifth year civil engineer. My name's Matt Skiles and I'll be graduating in May.
I'm a fourth year geological engineering student. I'm Joey Resner and I'll be graduating next fall.
I'm Christine. I'm a senior majoring in geological engineering.
I'm Connor Pusai. I'm a senior and I'm a civil engineer, and I'll be graduating in August.
I'm Chase Rovers. I'm a fifth year senior in civil engineering, and I'll be graduating in May as well.
Okay, so today our group will be representing the public for the Guatemala City landfill and also our proposed design solution. So just a brief outline today. First, I'll just give you a little background on the landfill itself. Then we'll talk about our proposed solution, actions to take, detailed plan of this project, and briefly go over some of the finance issues. Then we'll talk about some of the benefits that arise from having this landfill here, and then finally conclude. In this image here is just a map from Google Images showing the boundary of the landfill, and as you can see here, it says covers an area of about 75 acres. So a little on the background, this is the largest landfill in Central America. One of the biggest problems with this landfill that there is no restriction on the materials disposed there, and also there's no compaction performed here, which those two things together cause some big problems in the area. Also, with the dense population in the area, there is many scavengers living around here. There's some even actually living in the landfill, and they scavenge here to make a living every day.
So these scavengers, these people who live in the landfill and basically live, breathe, eat, and survive around this landfill are called guajaros. And what they do is basically they survive by collecting food, metal, clothes, basically any materials that they can use to try to resell, use for themselves, repurpose, basically incorporate in their daily lives to try and make a living off of other people's refuse. Kind of a living example of one man's trash is another man's treasure. Based on this, there's an estimated 11,000 guajaros that live around this landfill in Guatemala City, which is huge. Again, since it's being the largest landfill in Central America, there's that many people dependent on it. Approximately 10% of those who work and live within the landfill are children. So not only is it unsafe for adults, but these children who are unsupervised, unskilled, prepared for the world around them, live and breathe and work daily in this landfill under these treacherous conditions. And on average, these people make only $1.50 US per day. So you can see, even with all of the way that this is so hazardous, even with all of that, they're not, kind of getting the reward for their risk. They're only making $1.50 per day, which is barely enough, to buy a candy bar in America. So. In April of 2016, the land.
Okay, so in 2016, there was an accident that occurred at this landfill. This accident was due to a landslide that actually claimed 4 lives and also a reported 20 people missing. This landslide occurred because of the previously mentioned pretty much poor to zero compaction on the landfill. And also the area that this landfill is in Guatemala City, steep slopes and heavy rainfall make it a perfect victim for landslides to occur. Also, there's poor leachate management here, which also causes problems to arise.
So we as the public want to talk a little bit about why we think we deserve some action from the government. There's definitely the potential for a landslide to happen again, especially if nothing gets done. And the living and working conditions are just unacceptable. There's a lot of air pollution created by the lack of gas management, so one of our proposals is to put in a gas management system. All right, so our desired government action, number 1, we want to implement safe working conditions. And the main way we want to do this is through proper training and to purchase equipment for everybody, such as safety vests and hard hats. We also want the government to fund the purchase of a compactor to use after sorting. And lastly, as I talked about before, we want to put in the gas management system and use that to generate power to the local communities. All right, so for implementing safe working conditions, we really want to focus on employee safety training, including the recognition of some of the dangerous materials that do go in there. And then we want to reduce risk of injury with the sorting station, and I'll talk more about that in the next slide. And so lastly, some of the proper safety equipment we want to buy are hard hats, safety vests, protective eyewear, and proper footwear, just some of your basic things. All right, and then our sorting station, we want that to mainly prevent hazardous materials from ending up in the main landfill. And this is another way we can create jobs by hiring employees to help sort out the dangerous stuff. And we also want to make sure the scavengers still have a way to live. So we're going to use this sorting station before compaction so they can pick out things that will bring them profit.
So in the use of compaction in this landfill isn't currently being done, so we want to implement a compactor into the site. We have chosen a CAT 826K landfill compactor. This is because it generates enough force down around the ground in order to compact efficiently. It's also large enough and fast enough to pass over for such a large site, fast enough, make enough passes per day that it allows efficient compaction. The biggest reason to do this is to stabilize the daily cells, the daily loads, and the daily cover in the landfill. It maximizes site efficiency, allowing for a maximum amount of volume or a maximum amount of waste to be stored at the site. It also reduces the chance of landslides, which is our major goal here, making the conditions much safer. It also, by making multiple passes per day, it again improves efficiency, which allows more waste to be used in the site.
So for the gas management system that Christine talked about before, this is a necessity. It needs to happen in the landfill. Due to minimizing gas migration from the boundary of the landfill and into the people's homes nearby, reducing the greenhouse gases and effects that has on the impoverished areas, and basically reduce landfill fires, which is also a problem with the landfill in Guatemala, and allow energy recovery when it's feasible. So to get started with the landfill gas management system, we want to do some compliance monitoring just on 5 main parameters of methane, CO2, oxygen, atmospheric pressure, and temperature. This will give us a general idea of what is happening in the landfill, what we have to work on, and monthly goals will be assessed for each of the parameters. Hopefully we can achieve a goal that is good for environmental standards. So as for the gas to energy management system, how it works, generally we have gas collection wells that collect the gas in the landfill. These are transferred to a gas extraction and cleaner plant that we have to create. This gas produces an energy or an electrical generator that goes into a transformer and could possibly go to the grid, but we're not sure if there's a grid in Guatemala. So maybe we could create one or get the government to make one and be more beneficial.
So this type of gas collection system, it's a bit more difficult to implement when there's already a lot of refuse in the landfill. One particular case study we found that was a good idea is one that occurred at the Coquitlam landfill in Vancouver. This was also applied to a pre-existing landfill. It's slightly different because they had a gas collection system. This is just an upgrade, but we'd like to see a lot of the same tactics implemented in the Guatemala City landfill. So this particular study was carried out in 2013. It was on a much smaller landfill. It was only 0.13 square miles. But all the gas that was produced was used to fuel the local paper recycling plant that was very near the landfill. So this is just a matrix of the baseline gas production and collection estimates for the landfill, as well as 10 years of projections until 2021. So as you can see, before the project was implemented, the landfill produced about 700 tons of methane per year, and it was only about 44% efficient at capturing that methane. But with the new system, the efficiency improved to 75% after 5 years or so. And we'd like to see that same type of production in our landfill. And this gas fill collection includes it's an impermeable barrier layer that traps all gas inside of the landfill, including CO2, which is obviously important for global warming. The projections for this study estimated that there would be absolutely no CO2 emissions out of the landfill. And after the 10 years, they estimated that they would collect over 3,000 tons of methane, which would be very beneficial to the local population, as it could produce some much needed energy that otherwise might be produced through the burning of coal or other sorts of biomass that release harmful particulate matter into the air. So, as I mentioned before, there's a lot of concerns with air pollution, specifically particulate matter, and that's one of the unseen hazards of the people that live in and around the landfill. The lack of gas management sort of leaves the emissions completely unchecked, and the persistence of landfill fires combusts a lot of solid and liquid material that turns into gaseous emissions and particles that are ingested and can infiltrate the lung tissue and cause all types of cancers and other medical issues. And this is just a matrix of United States standards set by the Environmental Protection Agency. And as you can see, for particulate matter of 2.5 microns in diameter, there are standards set at in the teens and about 35 for 24-hour averages and annual means, etc. For PM10, the standard is 150 micrograms per cubic meter as a 24-hour average. But a study conducted in 2012 by the local University of San Carlos measured that the average annual particulate matter contamination 2 miles from the site was 94 micrograms per cubic meter. And if that's the average over the course of an entire year, it's reasonable to assume that any number of these standards can be broken, considering the rather stringent concentration standards for the smaller particulate matter in the air.
So getting into what we want for this project to be seen, we can see a typical section of the proposed landfill. Along the right side here, you see the existing canyon wall and existing soil that would be used. A clay liner and barrier, as well as a geotextile barrier, would be implemented along the bottom as well, all the way up the side to the top, as to not allow toxins and things to get into the existing soil and contaminate those areas. On top of that, you'd see another geotextile layer, as well as a drainage layer that will allow all of the leachate that came down through the waste to be contained and disposed of. On top of that then would be a geotextile layer before we get into the daily cover layers and the cells of daily refuse. And then within this area, until we get up to the solid waste, we then get up to the capping layers, which includes another geotextile barrier, a gas vent system, another compacted clay liner as to not allow, again, contamination into the topsoil. And then you would see another drainage layer and a topsoil layer and then surrounding vegetation. So when this is all done, it's the canyon fill and usable with topsoil that can be repurposed for vegetative areas such as parks or soccer fields or things of that nature to help benefit the community. And all in all, this would help contain all the leachate and the chemicals and the contamination from entering groundwater that the community used to drink, surface water that they use for other things, soils that they might impact for construction down the road, and things of that nature. So really just to improve the safety and general of all the surrounding communities.
So as far as financing goes for the landfill, we as the public believe that we should not be completely responsible for the cost of this project. And we also believe that we deserve the best option available considering the circumstances. Also, the government should spare no expense, and the cost of this entire landfill should not come from raised taxes.
So some of the overall benefits that we would see from in implementing this landfill is safer working conditions, which will prevent future loss of life, which is something that's been very prevalent lately. It would also prevent future landslides. And one of the biggest problems with landfills is the emission of air pollutants. And by increasing safety, we would improve the quality of air surrounding the landfill. And also through gas collection systems, we would also be able to generate electricity. So in 1996, in Danbury, Connecticut, there was a landfill fire, and they decided to extinguish the fire with water, and this ended up promoting bacteria growth and increased the production of odor-causing sulfides, specifically hydrogen sulfide. And we looked at this and how the landfill operators responded in this case, and immediately they added a landfill liner gas collection system and a flaring system for a long-term solution. And then they also informed the community about what was being done and how they can remain safe in this situation. And we're looking at modeling our situation after this. In addition to this, we're thinking about the children. Studies show that kids that live near landfills are hospitalized more frequently and develop respiratory infections, and this is also, paired with this is also increased asthma rates, and this is why we need to take more precaution in bettering the living conditions around the landfill.
So in conclusion, we think as the public it's very important to provide solutions to the community in order to prevent children like seen here from living in such dire conditions. Having a community that's so close to this landfill and so dependent on it, but also they live or die by it. They depend on it, but also it's killing them. So coming up with a solution that's both viable for them in the long term for sustainability economically, but as well as a lifestyle is really important. Unless you want to continue to see children die at an alarming rate and future generations to be, completely exiled from, the modern world, it's imperative that we fix this solution or fix this problem and come up with a solution that's good for everyone. Thanks.